Right, dear viewers, I take this opportunity to welcome you to this lesson 3 of electrolysis. Now, in lesson 2, we had ended at a point where we had clearly shown that metals are conductors and they use the free mobile delocalized electrons to conduct electricity. You understand? Yes. So we are talking about electrolysis, and then in electrolysis, as I told you at the start of the topic, that here we look at the decomposition of compounds by using electricity, hence the name of the topic, electrolysis. I told you that lysis means to break down or to decompose, and then electro comes from electricity, or call it electric current. So clearly meaning that the breakdown or the decomposition of a compound by passing an electric current through it is what we call electrolysis. Alright, so now we are moving forward with our discussion, and I'm saying that we have finished the issue of metals using the free mobile localized electrons as their conducting particles. Yes, is it only metals that conduct electricity? No, we are also saying that solutions of ionic compounds, or ionic compounds in the molten state, okay, solutions of ionic compounds, call them aqueous solutions, because here we are looking at water being used as the solvent, and you must know that whenever water is used as a solvent, the solution formed is called an aqueous solution. So solutions of ionic compounds or ionic compounds in the molten state conduct electric current, conduct electric current, and they are called electrolytes. That is very, very important. Yes, now we are saying that electrolytes contain free mobile ions. Electrolytes contain free mobile ions that enable them to conduct electric current. All right, now this is another important thing here. We are talking about the mobile ions. Remember, for the metals, we said that the conducting particles are the free mobile delocalized electrons. And now we are saying that for the electrolytes, it is the mobile ions. So you have to take note of that. Whenever a question comes and they ask for the conducting particles in one, maybe copper metal or magnesium metal or any metal, there the conducting particles are the delocalized electrons. But if it is molten lead to bromide or sodium hydroxide solution or sodium chloride solution or molten sodium chloride, you understand? Yeah, it is molten sodium chloride. You cannot have molten sodium chloride solution. Many of you want to have very long sentences, so you end up saying molten sodium chloride solution, which is wrong. So we are talking about ionic compounds. However, we are going to reach somewhere and we see that it is not only the ionic compounds that can act as the electrolytes. We are going to see that most of the non-electrolytes are covalent compounds because they are made of molecules, you understand? But we shall see that there are also some covalent compounds that act as the electrolytes. All right, so now we are saying that these ionic compounds, to act as electrolytes, they should either be in the solution form, they should be aqueous solutions, or they should be in the molten state. So what does that mean? It means that these ionic compounds in their solid state, they do not conduct electricity. You understand? Yes, and when these ionic compounds are in their solid states, they can never act as electrolytes, meaning that they cannot conduct electricity, they cannot conduct electric current. So I think it is very, very important to get an answer for this question. Yes. What is the question? The question is, why are ionic compounds in the solid state, why are ionic compounds in the solid state non-conductors, or you can say, why are they regarded to be non-electrolytes? Why are they regarded to be non-what? Why are they regarded to be non-electrolytes? Yes, now, to understand this very well, we need to first move back. To what we called ionic bonding, because it is ionic bonding that brings about the ionic compounds. You understand? Yes, it is through ionic bonding that we get ionic compounds. So if you remember the properties of ionic compounds, you were told that ionic compounds do not conduct electricity in the solid state, but they conduct electricity in the solution form or the molten state. So why? So that's what we want to remember, and then after remembering that, we shall be in position to get an answer for this. All right, so now we are going to have an example. We are going to first illustrate the formation of one ionic compound here. Yes, and then after using that example, we shall be in position to handle all other ionic compounds. All right, now before we get the answer for this question, let us first look at the formation of sodium chloride. Yes, consider the formation. Let us consider the formation of sodium. Let us consider the formation of sodium chloride. All right. Now, sodium chloride is an ionic compound. Why are we saying that sodium chloride is an ionic compound? Because it is formed from a metal atom, that is the sodium atom, combining with a non-metal atom, which we call chlorine. But you will understand that these non-metal atoms, yes, these non-metal atoms in ionic bonding, as we are going to see, they do gain electrons. And when they gain electrons, they form ions, the negative ions, which we call anions. And when they become anions, their names change from the original names of the atoms to the names of the ions. And then the anions, that is the ions of the those are the ions of the nonmetals. We are saying that their names end with the IDE. For example, chloride from chlorine, sulfide from sulfur. You understand? Yeah. Like that, nitride from nitrogen, oxide from oxygen. You understand? So now, after these non-metal atoms gaining electrons, then their names they end with IDE. So you can use those examples I have given you: oxide, sulfide, nitride, chloride, and very many others. All right, so now for the metal atoms, for them they maintain their names. For example, the sodium atom forms the sodium ion. The magnesium atom forms the magnesium ion, like that. All right, so now here, wonderful children of God, we are going to look at the formation of the sodium chloride, and that one will take us to the point of saying that the ions are the conducting particles of the electrolytes. All right, we are still in lesson 3. We continue to encourage you to inform your friends about this YouTube channel. Let them subscribe, and then they learn with us. Yes, let them not miss. All right, now, dear wonderful children of God, we are considering the formation of sodium chloride. I believe when you were in senior 1, you learned about the writing of chemical formulae. And I believe right now you know the chemical formula of sodium chloride. All right, so sodium chloride is NaCl. How does this come about? We can have it as our side work. Sodium has a valence of 1, and then the chloride radical has a valence of 1. Now, whenever valences are the same, you simply ignore them. Combine what remains, and then you come up with the sodium chloride. Are you worried about where we are getting the valences from? By the way, for your information, when we talk about valence, valence is the combining power. Is the combining power of an element or a radical. Yes, combining power. So that's why when you are looking at the periodic table, you said that the group 8 elements, they do not react, they do not combine, because their valence is 0. And why is their valence 0? Because their outermost energy levels are filled with electrons. So that is some good chemistry coming from senior to work. All right, now we are looking at sodium chloride. Whenever you are going to illustrate the formation of any compound, okay, yes, be it ionic, be it covalent, at your level, at least those two, make sure that you know how to show their formation. So you have to look at the number of atoms. When you look at sodium chloride, there is 1 atom of sodium and 1 atom of chlorine. So that clearly means that 1 sodium atom combines with the 1 chlorine atom to form the sodium chloride. Still, let us get some info from atomic structure. Who remembers the atomic number of sodium? Right, the atomic number of sodium is 11. What of chlorine? Yes, chlorine is the 17th element in the periodic table. Sodium, the electronic configuration, I understand you are experts here. The electronic configuration of sodium is 2 to 8 to 1. And that of chlorine is 2 to 8 to 7. I believe you can all write that. Alright, like we've said before, whenever you write an electronic configuration, and that electronic configuration ends with 1, 2, or 3, that one is a metal atom. Clearly meaning that that atom is coming from either group 1, group 2, or group 3, which are groups of metals. Yes. Now, this one, group 5, group 6, group 7, group 8, those are non-metals. You understand? So, I believe that you know that chlorine is a non-metal. So, last time we said that metals react by losing electrons. And then non-metals react by gaining electrons. The loss of electrons is what we call oxidation. And the gain of electrons is what we call reduction. Alright, now, whenever we are illustrating bonding, yes, we use the valence electrons. Yes, yes, we use the valence electrons, or we use the outermost energy level. So, when it comes to sodium, we shall clearly see that, I hope you clearly see that, sodium has 1 electron in the outermost energy level. That is the sodium atom. Then we have the chlorine atom, Cl. Now, for this chlorine atom, here for 1 atom, I have used the E to represent an electron. Then, for this other atom, I'm going to use X. Yes. So, there are 7 of them. 1, 2, 3, 4, 5, 6, 7. Alright, so what happens in ionic bonding? What happens in ionic bonding is the complete transfer. In fact, along with this arrow, you can write electron transfer. Yes, in ionic bonding, what happens is the transfer, complete transfer of the valence electron or electrons of the metal atom to the non-metal atom. So that means that the metal atom loses, you understand? And then the non-metal atom gains. And you must remember that whenever an atom loses or gains an electron, it forms what we call an ion. And if you do remember very well, metal atoms form cations, the positively charged ions, and the non-metals form anions, the negatively charged ions. Alright, now, what shall we have? You will put these 2 brackets here with a dot here to represent the ionic bond like that. Okay, now we draw the outermost energy levels there. All right, to start with the sodium. Now, sodium, it had one electron in the outermost energy level, and it has lost it. So this energy level ceases to exist. So that means that now the outermost has 8 electrons. And since for sodium we use the Ne to represent the electrons, that means that now our outermost energy level, because now this one has been lost, the outermost energy level we have right now has 8 electrons. So you put them there. 1, 2, 3, 4, 5, 6, 7, and 8. Now this is for sodium. But remember, when a metal atom loses an electron or electrons, it forms a positive ion. So that means that I have to write the charge here. But the size of the charge depends on the number of electrons lost. Since the sodium atom has lost one electron, it forms a unipositive. I will put it up there. And then, what about this chlorine atom? After gaining the electron, it becomes a chloride ion. It becomes a chloride ion, all right? I will write the Cl there. And then I write the electrons, X, 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 the way you see it here. Now, X, and then an E that has come. So, who can tell me the charge I have to put here? Yes, I will put a -1. Why do I put a -1? Because a chlorine atom has gained one electron. And remember, electrons are negatively charged. Alright, hope you can clearly see that now the ions are coming. We have formed the sodium ion, positive, a chloride ion, negative. And I'm saying that this bond, okay, that holds these two ions together, it is the ionic bond. It's the ionic what? It's the ionic bond. Okay? Yes. Now, this ionic bond, as we conclude this particular lesson, has forces of attraction. Yes, this ionic bond contains what we call the strong electrostatic. The strong electrostatic forces. The strong electrostatic forces of the strong electrostatic forces of attraction. When we talk about electrostatic forces of attraction, these are forces of attraction between oppositely charged ions. So now we are going to continue from here. Now let me hope you have clearly seen that in this formed ionic compound of sodium chloride, we have the sodium ion and the chloride ion. Yes, they can clearly be seen here, all right? So, in our lesson 4, we are going to start from this point. You have seen how these ions are generated. So, we are going to start from this point, and then we shall continue to see why is it that the solid ionic compounds do not conduct electricity, yet ionic compounds dissolved in water form aqueous solutions, or the molten ionic compounds, why for them conduct electricity and why they are called electrolytes. Thank you for viewing. Let's meet in lesson 4.